Okay, continuing with problem number 15. So I was in the kind of towards the end of that problem. I was in the phase where I was resubstituting. I'm going to do that for this problem also. X to the 1/2 is equal to 2. So now you have these equations. Try to remember what I was trying to remind you of from your knowledge of radicals. Radicals can be written as a fractional exponent, where the power that's on the variable inside the radical, that'll be the top of the fraction, and this index is the denominator of the fractional power. So if that be the case, that what you're looking at right here is square root of x, and you don't have to rewrite it in radical form. You could have just went right from here and gotten the answer, but just thought I'd write it like this for you. That's what you're looking at. You still don't have the answer for x because you've not solved for x when there's a radical wrapped around it. So you're going to have to raise this to a power of 2. Likewise here, and you get x is equal to 144. Continue with this one. Get rid of the square root by squaring. Squaring is the opposite of taking a square root. Therefore, you have to raise this side to a power of 2 as well. And then those are your two answers. Okay, so moving on to number 10 and 10 sevenths. Moving on to number 16. There's a lot of the substitution type problems here. Okay, so you learn how to do the substitution procedure so that you can make it look like something that you're familiar with. You don't know how to factor these. When you get if you get to pre-cal or calculus, you will be able to leave them like this and factor them just like this. But while you're trying to ease your way up to that level of knowledge, you use the substitution process. You substitute right here at the power in the middle. So you're going to let u be equal to that x to the -1, and then you're going to rewrite this. Be aware that x to the -2 is the same thing as x to the -1, that power right there, times x to the -1. And then this is 5x to the -1 minus 6 equals 0. So if you're allowing u to be equal to x to the -1, that means that everywhere that you see a u, or each place that you see an x to the -1, you can replace it with u, which is why it's called the substitution procedure. Don't forget, if you're going to substitute whatever is complicated right out of the problem, you're going to have to resubstitute again at the end, because all you're going to be doing here is solving for u. Same kind of factoring method that I've used in the last two problems. The two numbers that multiply to give you 6 but add to give you 5 would be 6 and 1 if you allow one of them to be negative. So positive 6 and -1 is what would work. That times that is -6, but you should also be able to add these numbers to get that number, and you can. When you make a linear equation out of that factor as well as this one, you get two semi-solutions. They are not really the full solutions yet because you still have to resubstitute. Okay, going back to this definition that you established at the beginning of the problem, u is equal to x to the -1. So resubstitute and resubstitute for this one as well. Now we're going to get the real solution. So back to your knowledge of things that have transpired in previous courses, and we're here to solidify them even further. X to the -1. Let's recap how to rewrite a negative exponent. That really means this. 1 over x to the +1. By the time you bring this base down to the denominator, the power goes from being negative to positive. That's how you rewrite a negative exponent right out of the problem. So that's really what you are trying to solve. Okay, you also may be rusty with how do you solve this particular type of problem. You can just do what's called a one-way cross multiplication. So instead of, if you do cross multiplication both ways, you're going to introduce an extra step that's really not needed. So whenever your variable is down in the bottom, you can just do this simple switch, and that'll cut out one of the steps instead of doing full-blown cross multiplication both ways. So bring this down into the denominator, that -6. All they're going to do is swap places. A little shortcut for you. Okay, the -6 came down here. The x went and popped up in its place, and there you go. You have one of the answers. Likewise over here, x to the -1 is really 1 over x to the +1. And then when you go to solve, just you only do this when your variable that you're trying to solve for is down in the denominator. Let the 1 come in its place and the x come in its place. So your other answer is just 1. Okay, that's number 16. Number 17 is, let's see, another one of these crazy looking problems. Calling for substitution. Okay, so again, get right in here, do the substitution at the center. X to the 1/3, rewrite the problem. Keep in mind that what you're seeing right here, x to the 2/3, is really x to the 1/3 times x to the 1/3. And of course, it has a 4 right there. I'm just trying to make you see what's hiding inside of the x to the 2/3 so that you'll understand how to substitute this u properly. Okay, so this is 4. Every time you see an x to the 1/3, you're going to put a u there. So this front term becomes 4u squared. Then it's 4u minus 3 equals 0. When you go to factor this sort of thing, let's see. Now you're going to look for two numbers. Now this is called the advanced version of guess and check. It involves you rewriting this problem as a grouping problem. This seems to work the best for students, and it starts off like this. You're going to look for two numbers multiplied together that give you the A times C value. Remember, this is A, this is B, this is C from your work with the quadratic formula. We're going to look for two numbers, knowing our times tables, that is equal to A times C, 4 times -3, -12. But the two numbers that we come up with have to also equal this number in the middle. So the only thing that's different between basic guess and check and this extended version is that instead of just plopping the C value here, it's A times C. So this step right here is a little bit different. All right, the numbers that would work there would be -12 and +1. They would work both here and here. And the numbers you come up with always have to work in both this step and this step. Okay, now, because the reason that you are going to have extra steps in this advanced version of guess and check is because that leading coefficient is bigger than 1. So now you're going to use these numbers to rewrite the middle term. This is probably the hardest factoring method. It just has a little extra in it. So we have that front term. And instead of a -11u, you have -12u. That's what this number, but with a u on it, and +1u. Together, those two terms add up to -11u. Now, instead of the 3 terms that you have here, you have 4 terms. and it turns into factor by grouping. If you group the front two terms, you can take a 4u out. And if you group the back two terms, they have nothing in common. So we say that the GCF we're going to take out, this is the GCF for the first two terms. But when two terms have nothing in common, we say the GCF is 1. Put the parentheses, and you still have u minus 3. This GCF that you've taken out, you should be able to multiply it to get that term, multiply it to get that term, if you pulled it out properly. This had nothing in common, so we pulled out a 1, but notice that this 1 times u is 1u, while this is negative 3. At that point in the factor by grouping method, you're now looking at two terms, and they have a GCF, which is this entire expression inside the parenthesis. So take that out as the common factor, while what goes back here is 4u plus 1 is equal to 0. So it's u minus 3 is equal to 0. 4u plus 1 is equal to 0. And you have an answer equal to 3 when you bring this over here. And for this one, it's 4u equal to negative 1. Dividing off that 4 will give you u is equal to 1/4. But remember, you are not looking for answers for u. You're looking for answers for x. So now re-substitute. Bring those x's back into the problem. So for this u, you're going to have x to the 1/3. While for this one, you're going to have x to the 1/3 is equal to negative 1/4. So reminding you of problems that happened earlier in this section, you can rewrite it as a cube root if you want to, or you can leave it like this in power form. You don't have to write it in radical form. If you want this not to have a fractional power, then you better get rid of the denominator. So earlier in this section, I was showing you how to do that. Just look at the denominator and raise it to that power. Don't forget, always do the same thing to both sides. So when you raise one power to another, you really multiply the powers. That's the power to a power rule. So this ends up canceling out, and you have x to the first degree is equal to 27. So that's one of your answers. Likewise over here, you can just get rid of this fractional power like that. Don't forget to do the same thing over here. So this will be equal to x to the first degree. Here it's negative 1 cubed. You got to cube the top. Negative 1 times negative 1 times negative 1. That's negative 1. And you also have to cube the bottom. You could always put that in your calculator. 4 cubed is 64. Okay, that gives you the answer for 17. I don't know that I'm going to get to do many more of these, but you can always go into My Math Lab and push help me solve this, because at this point I've done almost 90% of these problems. I'm going to try and do one more, but I might get cut off in the middle of it. Let's see if there's anything that's different than what I'm doing. I'll jump to number 20, because the next two problems are more of that substitution, and I've already done 5 examples. So this is the last one. This time, unlike the other, the last 4 problems that I've done, you have an entire expression that you're substituting right out of there. See how you have the same expression here and there? So you could let u be equal to x plus 9. So it would be u squared plus 10u plus 21 is equal to 0. And you can factor it as I have the last 4 or 5 problems. The numbers that multiply to give you 21 but add to give you 10 would be 3 and 7. That gets it factored. You're going to get u is equal to negative 7 for that one. U is equal to negative 3. Don't forget, re-substitute. So in for u, we let u be equal to x plus 9. We will put x plus 9 equal to negative 7 and solve it by bringing this over here. And that would be negative 16. And then for this other answer, x plus 9 in for u. just like we put x plus 9 in for u right there. Bring this over here.